Hey there, welcome back to another video with the Math Doc. We're talking about equations with absolute value terms, and we're still looking at very simple problems where we have only one variable term, and that term is within the absolute value brackets. The previous video linked, you can find the explanation of how we solve linear equations with absolute values. In the meantime, if you're new to this channel, please subscribe and let's get started. So I brought in here a word problem and let's get started. Let's read it out. We'll highlight the important information and we'll try to build a model like we always do with a word problem. So the recommended price for a Kawasaki Z400 motorcycle is $4,800. Let's highlight that. Okay. A salesperson has flexibility to negotiate and charge a little more or less. A good salesperson will not go above or below 15% of the recommended asking price. Write an equation for the minimum and maximum price. If the dealership pays the manufacturer $3,700 for the motorcycle, will they make money for the minimum selling price, and if so, how much? So let's write out this problem just in terms of the information we got. So we have a recommended price, right? The recommended price is $4,800. Okay, and the salesperson can go up or down, right? Up or down by 15%. Okay, and what we're looking for is the minimum and maximum they will sell the motorcycle for, right? So we probably need to figure out, first of all, what is 15% of this recommended asking price. So we have a video that I will link to this video which discusses percentages, and you can check that out here. And but as a reminder, when we have percentage, we can write that as a ratio. So we can write 15 hundredths of 4,800 equals 15% of 4,800. So let's calculate this. We can write this in a similar way as 15 divided by 100 times, and instead of writing 4,800, we'll write it as 48 times 100, because 48 times 100 is exactly 4,800. But now we have 100 both in our denominator and our numerator, which we can cancel, right? We have the equal product, the same coefficient, and now we can write this as just 15 times 48. Let's figure out what 15 times 48 is. So 5 times 8 is 40. We carry the 4. 5 times 4 is 20. So we have 24 with that 4. 1 times 8 is 8. And 1 times 4 is 4. And we get 0 here. We add 12 and carry 1. And that is 7. So 15% of 4,800 is just $720. Let's write that out as 720. Okay, so now let's go back to our word problem. The salesperson can go up or down by just 5%, right? So if the salesperson, let's write the asking price, not the recommending, but the asking price as S, capital S. Well, we know that our asking price has to be within 15%, but it can be bigger or smaller, right? So we can go, if we look at the number line, if this is 4,800, we can go up 15% or down 15%, right? Which means that we're looking at any number, okay, that is within a distance of 15%. from 4,800. So we can look in both directions, and that is a perfect situation for using absolute value. So in that case, our actual asking price minus our recommended asking price, which is 4,800, the minimum and maximum has to be 15% of that asking price, right? I'll write 15% up here, which we calculated right here to be 720. I'll write this out with units. Okay, so we have here our equation. S minus 4,800 absolute value equals 720. How do we solve this equation? Well, what we will do is what we did in the previous video. We look at two different cases. We look at the case where what's inside here is actually positive, in which case we don't have to worry about the absolute value brackets. We could just look at S minus 4,800 equals 720. But we also have to look at the case that S minus 4,800 is negative, right? In the case when we're looking at a lower price. So S minus 4,800 is negative, and therefore it equals negative 720. And we have to solve both these equations and look at the prices we get and make sure that they make sense in terms of results for this word problem. So how do we do this? We can add to both sides of the equation, to both equations, we can add 4,800 so as to isolate our variable. Remember, we try to isolate variables in order to solve. So we use the addition property here by adding 4,800 to both sides, and I will solve both these equations simultaneously because they're quite easy. So here we have minus 4,800 and plus 4,800, so these cancel. We have S equals negative 720 plus 4,800. And that means that S equals 4,800 minus 720, which is exactly 4,040. I mean 4,080, sorry. Let's look at our second equation here for the positive situation. Here again, when we add and subtract, we cancel these two numbers. So we have S equals 720 plus 4,800. So S equals 5,520. And both these results are in dollars, right? So we got the two results. So we can say that the minimum we can ask for is 4,080, and the maximum is 5,520. And these make sense for prices for the motorcycle. Now, there was a continuation to the question. Remember, we were asked if the dealership pays the manufacturer $3,700 for the motorcycle, will they make money? And so we can look, okay, so the purchase price for the dealership is 3,700, right? Yes. And so now we can ask ourselves, well, how much do we make if we sell the minimum amount? Well, we'll make 4,020 minus 3,700. So we will earn 4,020 minus 3,700, which is exactly $320. So the dealership will have a profit of 320, which is positive, so it will make a profit. So this first example was instructive in that we saw how we build an equation that includes an absolute value because we're looking at a problem where we can go in either direction. The only thing we know is that we can't go beyond a certain size or length. So let's go on and look at another example that I've included here. This is a similar example, and basically we'll be doing the same thing. We'll be building the equation and solving the problem. So let's look at this problem. A college professor plans a 45-minute lesson. Okay, let's highlight that, to include 20 slides. Okay, another number. She plans to spend 2 minutes on each slide, but knows she can sometimes go 10% longer or shorter on any given slide. Okay, so let's highlight that as well. Write an equation for the shortest and longest lesson plan. Is this a good lesson plan, or can she run over the 45-minute time of the class? Okay, so what are we doing here? Again, we have a percentage, and again, the error or the change from the original plan can be either to go up or down. So we can go either longer or shorter, and this time the difference is 10%. So let's write this out again in terms of just what we know so that we have this standing out. So our total lesson is 45 minutes, right? That's a given. We have 20 slides. That's a given. The length of each slide, okay, or the time spent, let's write that as time spent on each slide, is 2 minutes, but we can go 2 minutes plus 10% or 2 minutes minus 10%, right? So we can go either way. And so how do we do this? Well, again, we're going to have to figure out what our 10% is, right? And what we probably should do is we should look at 10% of the total time, right? So if we spend 2 minutes on each one, we expect to spend 2 times 20 minutes, right? Which is 40 minutes on all slides. Okay, and that is really within the 45 minutes, so that's okay, right? We expect to spend a total of 40 minutes. But we said that we might spend 10% more or we might spend 10% less. And in order to find the minimum and maximum, we have to assume that for the maximum, we're spending 10% more on all of the slides and or 10% less on all of the slides. So how do we do that? So let's look. Our total time is 40. What is 10% of 40 minutes? Well, we just did this, so I'm going to shorten this. We do 10 over 100 times 40, right? We have 10 as our percentage in a number with a ratio to 100 times 40. That equals 4, right? Okay, so now if T, let's call T will be our total teaching time. We know that on average it's going to be 40, right? Because we know that our average teaching time is 2 times 20, which is 40. So our real teaching time minus our average teaching time can be no more than 4, which is 10%. So that is 10%. So we are going up or down 10% in our teaching time, and we use the absolute value around t minus 40 to say we can go in either direction. So again, it's because we have 40 here. We can go up 10% or down 10%, right? And we found that the up and down are plus or minus 4 minutes. Okay, that's all in minutes. So now we can do our usual thing to solve this equation. We can look at the absolute value when the contents is negative, right? When what's inside is actually negative. In that case, t minus 40 equals negative 4. Or we can look at the positive um, side when t minus 40 equals 4. And both these equations, when we solve them, will solve the equality with the absolute value. But one will be for the minimum amount of time for the lesson plan, and the other will be the maximum. So as always, let's add to both sides 40 in order to isolate our variable t. We have t, these cancel, equals minus 40 plus 40. So t equals 36. So this is our minimum time, right? And this is in minutes. On the other hand, here too, we can add 40 to both sides of this equality, and we get t equals 44 minutes. Okay, so we have these two results. The minimum length of the lesson is t equals 36 minutes, while the maximum length is t equals 45 minutes. 44 minutes, and 44 minutes is less than 45, so we are still okay, and this is a good lesson plan. Okay, so this was our second and last example for this video. In our next video, we will discuss what happens when we have more than one absolute value, and we will also discuss what happens when we have an absolute value and a variable that is not within the absolute value. So sort of a mixed term kind of equation. We will do those, and then we will do word problems. But for now, if you're new to this channel, please subscribe, and comment if you have questions, and of course like, and I will see you next time.